Yep. Good evening, everyone. Chennai Camps, let's start off. Sure. Camps on, everyone. Where are the rest? Everyone is on vacation mode, kya? So the last thing we did was fraction, this thing. The next one. Where are these people? They'll not understand anything after this. Places given holidays from today?
Yes, sir.
You're free birds from today then. So made plans to go somewhere. Nothing. People got some parcels. Some people didn't get yet.
No, sir.
Aega. Diwali special assignments. Anika is smiling. Chalo. So we just have 1-2 concepts left. We'll wrap it up early only today. So let's see. Even I have come to my hometown. Apparent depth. So what is this apparent depth? Let's say we have a liquid. And let's say you keep an object at the bottom. And we have an observer on the exactly on top of the object here. So you'll observe these light rays will go straight. These light rays will have a slight refraction. So it feels, the observer outside will feel as if the light rays are coming from O dash. So this leads to, this feels as if this was the actual depth, this depth here is called H apparent. Hence, it is not real depth. So outside is mu observer. This is mu liquid. Derivation is not that important. So we will directly jump into this result. The H apparent is given by H by mu object into mu observer. I think you should copy down this formula here. The formula you can derive it from, approximations. We can find this angle to be, R, this is I, and then you can solve and get all that. It's not important. That is because, all these formulas that we have in ray optics are derived with so many assumptions, right? They really don't play much. So this is the formula. The apparent depth means it's not the actual depth. He thinks the object is at a different depth, but there are problems with this thing. There are a few conditions which has to be satisfied. So whenever you want to use this formula, the observer, the object, should be along the same vertical line. Should be along a line perpendicular to the interface. So if you have an observer here, and if you have object here, you can't use this. Because the light rays that reach him will be quite different. You can't use this. This is can't use here. The observer has to be exactly on top of it. Second thing, all these distances, right, which you're measuring, h and h apparent, are measured from the interface of the liquid. I'm sure this thing, right? You must have seen this. When I was in school, right? Outside our school, there used to be one guy. It was a game, you know. He used to bring a bucket of water. At the bottom of the bucket, he used to keep a small ring. And he used to give us some 25 paisa coins. So the game is for 1 rupee, he'll give you 4 25 paisa coins. Even if one coin goes and falls in that ring, you get 1 rupee back. So there was a game like that. We tried a lot, but it was so difficult. Meaning you have a first you think it is close by, then it is not. You'll see. This is how it kind of looks. The ring feels like as if it is much closer. And second thing, because of the drift, right? The coin should fall exactly inside. He never used to give the money, right? If it touches also. Look at this diagram here. If you see, right, the straw is supposed to be like this actually. Isn't it? But because of this thing, right, this point has gone here, this point has gone here, this point has gone here, and this point has gone here. The straw is something like this. You can see the apparent depth. If there was no liquid there, it would have been just in a straight line. But because of that liquid there, the straw was actually having a shift. It looks as if this got bent. The lighters are feeling much closer, whereas in reality, the straw is somewhere here. It is showing here. So this is the apparent depth. Clear, everyone? Udayan, Camson, who all are missing? 3 people are missing. So there. So main thing, this formula, you can use it only when they're on the same line. Second, these distances are from the interface. They're not distance between object and image. Let's see a question. This question will cover all the formulas.
So can you go back for a minute? Yes, sir. Thank you.
We have a aquarium. Filled with water. At the bottom of the aquarium, there is a mirror. And somewhere in the middle, exactly, there is a fish. At a depth D. So total depth of this thing is 2D. Exactly on top of the fish, there is a bird. This is at a height h. Outside is 1. Liquid ka refractive index is mu. Get in the scenario? So find the distance of The first one. Fish as seen by the bird. So fish as seen by the bird. Fish is the object and bird is the observer. So if you ask the bird where is the fish, what will it say? Bird as seen by the fish. So now bird is the object, fish is the observer. Fish image as seen by fish. The fish is looking at its own image. There is a mirror at the bottom, remember? Fish image as seen by bird. So the bird will think actually there are two fishes. One is the image and one is the actual fish. Bird image as seen by fish. So bird ka bhi image hoga. The fish will think there are two birds, one on the top and one at the bottom. Bird image as seen by bird. There, these are all the possible cases. If I ask you in the exam, I'll ask you the F case directly. But let's do one at a time. That will, you'll get used to the formula. Get all of them. I hope the question is clear. We have an aquarium with a liquid at the bottom. There is a mirror. There is a bird exactly on top of the fish. Let's get this. Venkatesh, Mayuresh, cams on. D by mu. No. Let me show you one. I'll show you one. The fish as seen by the bird. Listen carefully how I do these things. Fish as seen by the bird. So the fish is the object. The bird is the observer. Okay. The light rays will go from where to where? Light rays will go from the object to the observer. So light rays will go like this. Now see, this is how normally you can think of. Suppose if there's a person standing here right under the water, and if you ask him where is the fish, what will he say? D. If you're also inside the water and if you ask where is the fish, what will you say? D. If you just go outside, now see the formula is valid only when you just cross the interface. If you just go outside, now the formula is h apparent is the height of the object by mu object into mu observer. So here, where is the object? Object is the fish which is inside the water, so h by mu. So if you ask this person, the guy who is just outside the water, he will say the fish is d by mu. Are you getting it? If you put your head inside the water, you will think the fish is at d. The moment you put your head out of the water, suddenly it will feel it is d by mu. Are you getting this thing? So the person who is just outside the water will think d by mu. Now from here, if you take to the bird, what will the bird say? D by mu plus h. You're getting follow the light ray. Take the light ray from the object towards the observer. As long as you're going in the same medium, the distance will simply add up. But whenever you're changing the interface, suddenly the formula will be applied. And if I ask you this question, if you ask the bird in which medium is the fish, what do you think the bird will say? The fish will say the bird is in air. Are you getting it? Fish does not know what is water and what is all that nonsense. If the water is pretty crystal clear, no waves, nothing, Bird doesn't know that, there's a water inside. It'll simply think there is a fish at a distance of d by mu plus h. It is in air. The moment when you use this formula, the interface has become from water to air. Are you getting how I applied the formula? You can't apply the formula like this. You can't say d plus h by mu. That is a blunder. The formula is valid only for the distances are measured from the interface. I hope this was clear. I'll just show the second one also. Now the reverse. So this is my observer. The bird is the object now. Now light rays will come this way. So if you ask this person where is the bird, he will say h. If you just take him inside the water, he will say mu h. Now if you ask the fish, it will say mu h plus t. Making sense? You have to come the reverse now. Light rays are coming from air into water. So who is the object and who is the observer now here? The h apparent, the distance is h by mu object, that is mu air, into mu observer, that is mu liquid. Are you getting this? So this is mu into h. So if you just go inside the water, the distance will be mu into h. Then d comes into picture. D does not come from the beginning. Please check these two examples. Anyone not clear with this, please ask me.
So can you explain the B1 again?
Which part?
So the last.
This is h, na?
Yeah.
If you ask this person, what will he say?
So that
Just outside the water. He will say h only, right? You are in air, I'm in air, so I'll say h only.
Yeah.
But if you take this guy inside the water, what will he say? Mu h.
Yes.
So this guy will think the bird is in water at a mu h. And if you go inside the water, same medium, right? So it will just simply add up, isn't it?
Yeah.
Once you use the formula, you are just traveling within the same liquid, isn't it? There is no interface change. So mu h plus d.
Okay.
You're getting whatever this guy sees, the fish will see plus d extra.
Yeah, I understood.
That you got it, no? Everyone clear with this? It's a pretty good one. Clear? Now, can you do the rest? Now try. Take a minute for each one. It's okay if you get a wrong answer, but try. If you get a wrong answer, when I explain, things will get cleared. Fish image as seen by fish. Fish image as seen by bird. Bird image as seen by fish. Bird image as seen by this thing. Try. Take a minute for each. C will be 2D, right? If you have a mirror and if you have the fish. Now see, mirror doesn't care about the medium. If you keep the fish in the water, the image also will be in the water according to the fish. This is fish. And this is the fish image. So here it will simply be 2D. Mirrors don't create any problem for refraction. If you put water in front of the mirror, the image also will look like it is in water. So fish will think simply there is another fish on the other side at a distance of 2D. So same logic. This is the fish image at a depth D. So this bird will think there is a fish at a depth of 3D. So if you ask this person, he will say, where is the fish image? D. If you ask this person, where will he say? He will say 3D. If you ask this person just outside the liquid, he will say 3D by mu. And the bird will say 3D by mu plus h. Please check the answer. I hope you're getting what I'm doing. You first define who is your object, who is your observer. From the object, take a light ray and start going towards the observer. As long as you're traveling in the same medium, kuch problem nahi hai, just keep on adding the distances. The moment you change the interface, the formula will be applied, and after that, just keep adding the distances again. So every time you change the interface, you have to keep adding distances, or else you just keep adding as it is. Please check the examples A, B, C, D. Anyone not clear, please ask. It's a good question. It's not tough, but you should know what you're doing. Now try the fifth and sixth. Fish seeing the bird image, bird seeing bird image. Now you're looking at the bird image. Like I'm saying, if I have to ask you this question, I'll ask you the sixth one directly. Bird seeing the bird image. That's a good one. Try, take 2 more minutes.
Sir, can you show the questions again?
Let's see, show you. Look at the next one. We can do E and F together. Just give me a minute. Let's see. So first thing, the bird seeing the bird image. So the first problem is, who is the observer? The bird is your object. The mirror is the observer. You directly can't solve the problem. Because first you need to see, where does this mirror think the bird is? This is 2D and this is H. Now look at this thing. So if you ask this guy, where is the bird? Getting it? So light ray is going like this. He will say H. If you ask the guy just inside the water, he will say mu H. If you ask the mirror, where is the bird? It will say mu H plus 2D. So this will create an image here. This is bird image. So whatever the mirror sees, accordingly you'll get a bird image. So bird image will be at a distance of mu h plus 2d. And now if you ask this guy, now the bird image is the object. This guy becomes the observer. Now the light ray is going up again. This guy, if you ask him where is the bird image, he will say, there's a much faster way to do, but let's see the general method. The next one will make things clear. You'll get a faster answer though. We can treat the entire water like a slab and solve it, but let's see. This guy will say it is mu h plus 2d. If you ask this guy, he will say mu h plus 2d plus 2d. If you ask this guy just outside, he will say it is mu h plus 4d by mu. And if you ask the bird, it will say 2h plus 4d by mu. So this is the bird image as seen by bird. If you ask the fish, the fish will think the bird is here only, right? So fish will think it as mu h plus 3d. This is the bird image as seen by fish. Please have a look at this. Check your answer. So bird, seeing the bird image is 2h plus 4d by mu. Yeah, you got it. You got it. Anusha, you got it. Aryan, you messed up there. Please check. Anyone confused on this, please ask. Clear, everyone? Everyone got this?
So can
Any
you
doubts on
explain
this?
that part written in that light blue color bird image as seen by the fish?
Bird. Oh, fifth question we have na. Fish wants to see the bird image.
Yeah.
So that will be how much? Mu h plus 2d plus d, na? Because this is only d, isn't it?
Yes.
Fish is in the water. Bird image is also inside the water. So kuch problem nahi. Directly you can take the difference.
Okay.
Like I'm saying now, as long as you're in the same medium, there is no need to apply the formula.
Okay.
See, Abhinav, aisa hai. If you are in the same medium, mu object and mu observer both are same, right?
Yeah.
So mu cancel ho jayega. The problem comes when you are changing the interface.
Okay.
Clear with this, everyone? This is just based on the formula. We just kept a mirror and it becomes slightly complex. Clear, everyone?
Sure.
Alright.
Like instead of saying that the observer has to be on the same vertical as the object, could we say that if there's no relative velocity, the formula will work?
नहीं वो भी है अभी बाद में दिखाता हूँ. Bird starts moving तो things will go messed up.
Actually.
Relative velocity meaning basically the problem I'll tell you. See the formula na, when we derived it, we take like this very close light rays and we solve it. The derivation is not important. But if you take somewhere here na, you have to take these light rays and it depends where is the observer. You won't get such a beautiful formula. That's the problem.
Okay.
Clear? Next one. Let's say we have two slabs. And let's say we have an object at the bottom. Observer is exactly on top of it. This is H. This is T1, mu1. This is T2, mu2. Find the apparent depth. Find distance of O as seen by the observer. Mehan, are you there? Yeah.
Yes.
Keep your cam on. Keep your cam on. Again, just the formula application. Try, I'll give you a minute. We get a pretty good result. You can actually use this result for the previous problem, the bird seeing the bird image. That would have made it easy. But let's see what is the result. We have to derive it first. That looks weird, Aryan. I don't know. देखना पड़ेगा. When you simplify, you get a decent answer. This is T2, mu2. This is T1. This is mu1. This is your object. Look at this guy. If you ask him, where is the object? What will he say? He and the object are in the same medium, right? What will he say? T2. If you just take him from here to this medium, what will he say? Remember the formula? Depth T2 by mu object. Object is in mu2 into mu observer mu1. Is that clear? The moment you change the interface, the formula is the depth, whatever you are seeing, by, so lighters are going this way. We are going down to top. And if you ask this guy, now understand you're still traveling in the same medium. So it is T2 by mu2 into mu1 plus T1. If you're traveling in the same medium, you just add it up. Now you suddenly went out. If you go out, again, the formula will be whatever this guy is seeing, T2 mu1 by mu2 whole by mu of the object, that is 1 by mu1. This thing turns out to be just multiply T2 by mu2 plus T1 by mu1. So this is the answer. So this guy will see. So that person will see, he sees at a distance of H plus T1 by mu1 plus T2 by mu2. So you can simply replace the slab with a distance of T1 by mu1 and you can finish it off. Now you can extend this even for infinite slabs. T1, mu1, T2, mu2, Tn, un, right? Even if you have n slabs like this, let's take them. So if this is the object and this guy is here, so he will say the formula is h plus t1 by mu1, t2 by mu2, so on till tn by mu_n. The apparent depth will be h plus sigma ti by mu I. Check it out. We can make this even better. Let's say mu m is also there. Surrounding is filled with a medium mu m. I'll do one thing. I'll write in next page even a better version of this. Let's say the slabs are not touching each other. T1 mu1, T2 mu2. At a depth h and the surrounding is filled with medium um. You're getting? I am putting up a lot of things. Then the apparent depth formula will be h plus d1 plus d2 so on till dn. You just add all the distance between them. You can just keep all the slabs together. Then the whole thing will become what? H plus d1 plus d2 plus d2 plus so on dn plus t1 by mu1 mu medium plus t2 by mu2 mu medium so on till tn by mu_n mu medium. So this will be h plus sigma di plus mu medium sigma ti by mu I. So what you indirectly did was you just kept all the slabs together. You kept the object here and you kept the observer here and you took this distance as h plus d1 plus d2 plus so on till dn. Is that making sense? The medium between them, it doesn't matter. So you can just club all the distances together. Clear? This is a more generalized formula with you messed up everything basically. You kept medium between them, distance between them, everything you can do. Check it out. So it doesn't matter even if you have distance between the slabs. You can just come, make them closer and add that distance to h. Works. Check it out. So this is a general formula for that. Formula is, it looks good. Previous page here. Clear? Now, extending this a little more, you can actually manipulate this into another form. We'll call this apparent shift. So if you have a slab, if you have an object, and if you have an observer, if this is T1, this is mu1, and this is mu m, and this is mu m. Just now we saw, let's say, this was D1, this was T, and let's say this was D2. So just now we saw the formula H apparent will be D1 plus D2 plus T by mu1 into mu medium. So the shift will be actual distance minus apparent distance. That would be D1 plus T plus D2 minus D1 D2 plus T by mu1 mu medium. If you take a T common, 1 minus mu medium by mu1. What is this exactly? If this was the object and this was the observer, these light rays would go like this. They will go like this, and they will go like this. Not drawing properly. This person will think light rays are coming from O dash. Basically, he feel the object has shifted. The actual object is O, but you think it got shifted. So this distance O dash is your apparent shift. So whenever you keep a slab in between the object and the observer, he feels this thing has shifted by a distance of T into 1 minus mu m by mu1. Check it out. So this is the same thing. We have just used this formula here. The apparent depth minus the actual distance is the shift. Check it out. This is a better one to remember. From this, you can derive the previous one also. Either way, you can do that. You see which is more convenient for you. This will give you how much the object has shifted. The previous one will give you the actual distance between apparent distance. Please check this out. And the best part, it doesn't matter how it is. Let me write you that statement here. The shift is always in the direction of incident light rays. I'll tell you what it means. Most people get confused, like they understand it is shifting, but they get confused. Is it coming towards the observer or away from the observer? It should be always in the direction of the incident rays. Copied, everyone? But remember, this formula is useful for a slab, okay? The light ray should enter and leave from the same medium. mu m and mu m. If you mess up both the sides medium, this formula you can't use. Then you have to go back to the regular way of solving like this Fishenberger problem. If I make one side mu m1 and another side mu m2, you're gone. This formula won't work. Basically, the object and the observer are in the same medium. This is what I was saying. Ray optics is easy, but you should know your results and you should know when they work, when they don't work. Clear? Now, what do you mean by in the direction of light rays? Now see. Suppose object is here. And if light rays are going like this, I'm not drawing properly, but yeah, this is the meaning. So the shift will be in the direction of incident light rays. This is the shift. Suppose the light rays were supposed to meet here, but you kept a slab in the middle, meaning if the slab was not there, it would have met here. This kind of thing is called a virtual object. It was supposed to meet there, but you're not letting them meet. Then the light rays will deviate and they meet somewhere here, O dash. So here we are talking about this is the shift. The shift always happens in the direction of incident light rays. Clear? So if the light rays are supposed to meet at O, but you kept a slab, so they'll go and meet at the front. So this is a real image. Now, same thing you can extend for multiple slabs. Now, the best thing about this formula, I don't care what the distance between them because you want shift, isn't it? The apparent shift will be sigma ti 1 minus mu medium by mu slab. You just add them. Just take each one and you can just add all the summations. This is independent of position of the slabs. You can keep them anywhere. You can keep them together. You can spread them. You can touch them. You can keep distance between them. I don't care. This is the shift. That is the final formula. This is a more general formula if you have multiple slabs. Check it out. Remember, all these are slabs. And both the sides, the medium should be same. Let's see our question. Can I turn the page? Put it down, put it down. Let's see a question. We have a concave mirror. R is 20 centimeters. We have a slab here, 2 centimeters wide. Mu is equal to 2, and this is the object. This distance is x. Case 1, x is equal to 21 centimeters. Case 2, x is equal to 31 centimeters. Find the position of the image. Two different problems. Outside is 1. There. Now you can use your mirror, slabs. You can multiple combine them now. So you kept an object in front of a mirror, and between them you placed a slab of 2 centimeters and mu is equal to 2. Initially the distance is 21 centimeters. Find the image. When I say final image, meaning there should be no refraction or reflection after that final image. Just to give you an idea, light rays will go through the slab, shift, mirror, reflection, then again go through the slab, shift. So you have to apply the formula 2 times slab ka. Slab, mirror, slab. Get it? How do we do this? Try, take a minute or two. Then I'll show you the first one. Right, Adrat. Should I show you the first one? I'll show you one, say. So this is the object. Just look at slab, okay, one at a time. So what is the shift? Shift is t into 1 minus 1 by mu. Mu medium by mu slab. 2 centimeter. Medium is 1, slab is 2. 1 centimeter. Meaning whatever light rays are going, they will feel as if they're coming from 1 centimeter ahead. So now if you ask the mirror, where is the object? Mirror will say, I don't know who is O. Mirror will see O dash. And that is at a distance of 20 centimeters. So mirror will say, great, light rays are coming from the center, so they'll just go back. Mirror is over. Then for the slab again, now the light rays are coming towards the center. So they're supposed to meet here, but again, I know there's a shift. Again, it will shift by 1 centimeter. So what is the final answer? Same position, right? The light rays will retrace the path. You're hitting the mirror perpendicularly. The final image is on the object only. They're supposed to meet here at 20 centimeters. But you get shifted 1 centimeter again forward. Let me show you the full ray diagram. The final image is an object only. Answer is 21 centimeters. I told you this in the beginning, if you remember. If the light rays hit the mirror along the normal, they will always go back. So this was the object. The light rays went like this. then they got bent like this. And when you extend them, this actually became the center. So after hitting the mirror along the normal, they started coming back again. They went the same way, they came back again here. I hope the diagram is clear. So first you go 1 centimeter ahead. That mirror will think you're at the center. Mirror thinks object is at center. So it will try to send the light rays back to the center. But again, you have a slab in the middle. So the slab will again push 1 centimeter ahead. You get back at 21. I hope you're getting this logic here. Clear? Now do for 31 centimeters. Okay, someone got 61, someone got 11. Let's see. I hope the first part is clear though. Please ask me if you're confused in the first part. So when you have multiple things, this is what you do. If you have, let's say, 2 lenses, 2 slabs, and 2 mirrors, you do the same thing. First you do the lens, then the slab, then lens, mirror. You do one at a time. It doesn't matter how many objects you have. You can apply the formula one at a time. Do for 31 centimeters. Try, I'll give you a minute now. I hope you got the logic. Again, the shift is 1 centimeter. So this time mirror will think object is at 30. So uska image nikalo. Again, shift that. 61 nahi hai answer. That is too big. 11 bhi nahi hai. I don't know. 16. That looks right. Yeah, one answer. Anusha got 16. Anyone else got 16? Check. Look at this guy. So slab, object. I'm just showing you. Exam with we will not do like this. It's a waste of time drawing all. You can just manually see and tell. O dash, so the shift is 1 centimeter. The mirror will think object is O dash. This is 30 centimeter. That's why I give 31. This was over here. Remember? 1 centimeter ka shift. Apply the mirror formula. 1 by V plus 1 by U is 1 by F. U is minus 30. R is 20. So V is minus 15 centimeters. The lighters are going from here and then they're trying to meet somewhere here, image. Some people will get a doubt, sir, what if the slab is here? Doesn't matter. It will shift. What if the slab is here? Doesn't matter. The shift will always happen in the direction of light rays. Doesn't matter where is the slab. Then you have your slab again here. And then this is your eye. Again, this guy will shift to I dash. That would be again 1 centimeter more. So the final answer is 16 centimeters from mirror. Easy. Focal length 10. Be careful. Clear, everyone? Let's see the next one. Anyone not clear what happened, please ask. You just treat the slab separately, mirror separately, and then just use one after another. This easy one, this is. Let's see how they can mess up things. We got a slab here. X is equal to 0. X is equal to t. T is thickness. The refractive index is mu is equal to 1 plus x by t. It's a variable refractive index. And slab ka refractive index is not constant. at x is equal to 0, refractive index here na mu is equal to 1. Here the refractive index is equal to 2. Mu varies actually. Now find the shift. Outside is 1. So you have a slab with a variable refractive index. Let's get this. This is how we can bring calculus into picture. How do we do this? Who is missing today? Someone is gone. In case you're not able to make it, at least leave a message. Any answers? Try. I am asking you find apparent shift ray. Why do you want to find equation of the curve? Meaning, if you keep an object here, want like that, yeah, okay. If there's an observer here and there's an object here, what is the shift? How much closer it will come? वही है ना slab का formula t into 1 minus 1 by mu. So here you can't use that formula because that was derived for a constant mu. How much closer or how much farther will this guy think the object is? Apparent shift. Remember that formula we derived is only for constant mu. So what to do? Take a thin slab, find the shift due to the thin slab, and then integrate. Try. I'll give you a minute more. See. At a distance x, take a thin slab of width dx. So the small shift will be, remember the formula, t into, that is thickness, 1 minus mu medium, that is in this case it is 1, by mu slab. And it is given mu slab is 1 by 1 plus x by t. So the total shift will be, so this thin slab will shift this much, integral dx minus integral dx by 1 plus x by t. For people who forgot, the x plus b is 1 by a ln a x plus b. This much integration should be comfortable. Limits will go from 0 to t and 0 to t. This would be x, limits will be from 0 to t. This guy would be t into ln 1 plus x by t. So here a ka place में है 1 by t. Limits will go from 0 to t. This is t minus t ln. Put t there, you get ln 2. Put 0 there, you get ln 1. Ln 1 is 0 anyway. So t into 1 minus ln 2. Check your answer. That's the shift. Easy. You just have to know that you can take a thin slab. That is the whole point of integration, right? The slab is so thin you can assume mu is constant. If mu is constant, you can use a regular formula. This is the thickness of the thin slab. This is the shift due to the thin slab. If you add all the shifts, which we can do, remember, it doesn't matter where you keep the check. You can play with the slab refractor index like this. There is another way you can play with this. Have a look at this. I'll show you the second one. I'm lagging. No. No, I'm not lagging. I can see I have zero latency actually almost. Clear? Let's change this question a bit. This will be more interesting. So if they want to ask you in advance, they'll play around like this. So we have a slab. Let's say distance is d. D, okay. Refractive index mu is 1 plus t. T is time. Matlab refractive index is changing with time. Object is here. Let's say this is A. Observer is here. This is B. We'll keep it simple. Object is at rest. Observer is also at rest. But the refractive index is changing. Find velocity of the object image as seen with observer. I'll do one thing. Let's make this B and C. I'll tell you why I need that. What happens if the object and the observer are also moving? Then this ABC will matter. Now how will you do this? The refractive index is changing with time. So t is 0, it is 1, and then as time passes, it's becoming more and more. That means the shift is changing, no? If the shift is changing, that means it feels like it is moving, isn't it? At every instant, the shift is changing, meaning he thinks the object is not at the same place. That means it is moving. So find the speed. Find the velocity of the object as seen with the observer at time t. And you should use space here. Clear? How do you do this? No, first thing, if you see the apparent distance, the apparent distance will be A plus B, A plus C, plus that would be B by mu slab. That is a formula, B by mu. Agreed? So what is the speed then? So therefore, velocity of the object seen by observer will be differentiate this. D by dt, A, dc by dt, plus B d by dt, B by mu. Reason? What is apparent distance? This is the distance of the object as seen by observer. So if you differentiate that, you'll get the velocity as seen by the observer. Apparent distance is the distance of the object as seen by the observer. Luckily, in this case, even if you take shift and differentiate, you'll get the same answer. Now here, be careful, okay? What is dA by dt? In this case, I didn't ask you, but let's say this was the object. This is the observer. Let's say this is going with V1. Let's say this is going with V2. Let's say this is going with V3. Can you tell me what is dA by dt? Let me make it like this. Can you tell me what is dA by dt here? First of all, let's see what is A. A is the distance between the slab and the object. This is the distance between object and slab. So dA by dt is the rate of change of distance. In this case, what is V1 is doing? V1 is decreasing the distance. What is V2 doing? V2 is also decreasing the distance. It's the relative velocity minus V1 minus V2. Are you getting it? What is dc by dt? dc by dt is the distance between the slab and the observer. So when V3 is going, what is happening? It is increasing. When V2 is going, it is increasing. So it is V3 plus V2. Are you getting how am I taking plus and minus signs? If the velocity is responsible for increasing the length, it is plus. If the velocity is responsible for decreasing the length, it is minus. Both are decreasing A. Both increase C. So be very careful that A is not the velocity of object. It is the velocity of object with respect to the slab. Both increase. But luckily here, these are zero because I took everything as at rest. So this will be B d by dt. Mu ka value is how much? 1 by 1 plus t ka differential. So minus 1 by 1 plus t whole square. That's your velocity. Minus indicates it is actually going away from the observer. The distance is decreasing. It's coming minus v by 1 plus t square. So therefore the velocity is actually going right side. So b by 1 plus t ka whole square I cap. That's your answer, everyone. Check. So in this question, right, I could have made it more messy by saying object is also moving, slab is also moving, observer is also moving. Mu is also changing. That would have been more messed up. So if they are moving, then these terms ka differential will come. Luckily, B will remain constant. B is the thickness of the slab. So in this case, these two terms are zero. Have a look at this. Please have a look at this. Ask me if you're confused. Clear? This is a good kind of good question, where you're messing up with mu ka values. Because at apparent shift ka formula, there is nothing much, but you can play around like this. Clear? Next one. This is a good one. Let's say we have an aquarium. There's an object at rest. We also have an observer at rest. Refractive index is mu. Someone is pouring liquid into it. Liquid is poured into the container. Such that it rises with the speed of v meters per second. So the liquid is going up with the speed of v meter per second. The liquid level is going up every second, v meters. Find velocity of the object as seen with observer. Let's get this. This is a good one. Proper men's level question. Easy to do, but there is one where people goof up. Let's see whether you'll do that goof up or not. Try. You got a minute. Just give it a try. I'll be back in a minute. Let's see. V into 1 minus mu. I think some of you did get the idea there. And the observer is here. Let this be y. Most people forget this y. They think, okay, why do you need to take y? But you'll understand why. See, if you take the object here, so if you ask this person, where is the object? He will say x. If you take this person just outside the water, he will say x by mu. This person will say x by mu plus y. So the velocity of the object as seen by the observer is a rate of change of x by mu plus y. Now be careful here. I'm lagging a bit. Okay, so 1 by mu dx by dt plus dy by dt. Now most people think dy by dt is 0. It is not. Try to understand. When the liquid is going up, is x increasing or decreasing? X is increasing, right? So this is 1 by mu v. When liquid is going up, is y increasing or decreasing? Remember, y is the distance between the observer and the water level. Y is not the distance between object and observer. Y is the distance between observer and the water level. If the water level is going up, y decreases. So this is minus v. Got it? So most people forget this part dy by dt. So the answer here is minus v into 1 minus 1 by mu. Minus indicates it's actually going down. It's not going up. Check it out. This is the speed. So here there are two distances changing. X is changing, y is also changing. So most people forget this y part. What they do, they take apparent distance x by mu and they differentiate and they say v by mu is the answer. That's a mistake, so be careful. Now, how to make this a little more complex? See, same question. If I have to ask in advance, we have an observer. Observer is going down with v1. The liquid surface is going up with v2. The object is also going up with v3. All are changing. And this is mu. A differentiated shifted is correct. Yeah, that also works. But shift used differentiated. That should that might not work actually. Shift करेंगे तो work नहीं होगा रे. But luckily you got the answer, I suppose. Because your rate of change of x and rate of change of y was equal. So luckily you got the answer. You will goof up here. You will goof up here. Luckily because x and y are changing at same rate, na? देखो, I got here dy by dt, you got dx by dt here. Luckily it worked out. So that is wrong. Shift का work नहीं होगा. Now find it. Same question. Now all are moving. Liquid level is moving, object is moving, observer is moving. Find velocity of object as seen by observer. Clear? Same thing, we have to differentiate x by mu plus y. This is x. This is y. So here, what is dx by dt? That is a catch. So here, v2 is increasing, so plus, v3 is decreasing, minus. This increases x. When the liquid level goes up, x increases. When object goes up, remember, x is the distance between the interface and the object. That's why we get a minus sign. dy by dt, both are decreasing, minus v1, minus v2. So this is 1 by mu, dx by dt is v2 minus v3. dy by dt, that would be minus v1 plus v2. That's your answer, check. So this is what you do if everything changes. You need to be very clear what are you exactly differentiating. The same thing, remember mirrors mein kya tha humne? When you differentiate du by dt, what is u? U is the distance between the object and the pole. What you're getting is the velocity of the object with respect to the mirror. It's not in the ground frame. So be careful when you're differentiating, what are you exactly differentiating? So for that, you need to understand what the hell is x first of all. So if you define your x clearly, x is the distance between the interface and object, then you'll understand, oh, it's a relative velocity between them. But if you just say x is the water level, you'll get confused like what? Clear with this? Have a look at this. It's a pretty good problem. So in apparent shift now, they want to ask questions, they'll be framing questions of this sort. Slab ka thickness is changing, slab ka refractive index is changing. You can play around like this. Clear? There. So that's the last one for the day. So with that, we'll wrap up for the day. Right? I know people are happy. Right? So good. Go. Next week, there are no classes. Right? Next week, we are on a break. We'll again directly catch up on 21st. So you won't see me for almost 10 days. Don't forget. Then don't come and tell me, sir, we have seen you somewhere. And I did send 2 different sweet boxes. I didn't understand which one you will like. So I said, let's send both. Let them decide what they like.